Hey guys, welcome back to my new episode. This is your episode 9 and NSCA CSCS. So this chapter is about, or this topic is about the cardiovascular system, right? So here we'll be talking about heart. And basically all that we know is human heart has four chambers, right? So let me just quickly push the marker, right? So what you can see here is a human heart, right? And human heart is of almost a fist size, which has four chambers, right? Those chambers can be named as the left atrium, which you can see it here. You have the right atrium, you have your left ventricle, and also the right ventricle, right? So this is four chamber and two at the top, two at the bottom. The top are the atrium, the bottom are the ventricles, right? So you have the left side of the heart, and you also have the right side of it, right? So what we need to understand here in the heart is how the blood flows actually, right? So let's say we start from the left atrium, right, which you can see here in this, right? So ideally, it never happens this way, right? It always happens this way, right? It's the ventricles that pushes the blood out, right? So together, it's never a single ventricle contracting, right? It's both contracting together. But now, for easy understanding, they have keep it this way, right? So now, what you see is the left ventricle has the blood in it, and this blood is oxygenated, right? So as the ventricle contracts, right, the blood that is there in the left ventricle moves out of it, right, of the ventricle through the largest artery, right? So there's this largest artery called as aorta, right? From this aorta, the blood is going to be distributed, or I will say circulated throughout the body, where the body will receive oxygenated blood, right? So the body will use all the oxygen that is available in that blood, and in return, it will give, or it will leave with carbon dioxide, right? So what happens with this carbon dioxide, this blood has to be taken back to the heart, right? So how this is going to happen is this is going to happen through the veins, and the largest vein that we have in our body is called as vena cava, right? So what happens? The deoxygenated blood will travel back to the heart to the largest vein, which is called the vena cava, right? So let's take it this way. So from here, the blood goes to the body, right? From the body uses all the oxygen that's available or needed for the bodily purpose, then sends the blood back to the heart, right? So now here it is going to come back to the heart and will be entering the right atrium, right? So now this right atrium will have deoxygenated blood, right? So from here, again, the atrium has to contract, pushing the blood back to the ventricle. So what happens here, you will see an atrium contraction, pushing the blood into the right ventricle. What you can see it here, as well you can see it here, right? So what happens once the blood is in the right ventricle, which is deoxygenated? Again, there is a contraction, and this is I will say simultaneously both the ventricle contracts, not one at a time, right? So now both the ventricle will contract. The left ventricle will be pushing the blood towards the body, which is oxygenated, and the right ventricle will be pushing the blood towards the, what do you think? Right? It will be sending the blood to the lungs, right? So now, which you can see it here, right? So again, from right ventricle, the blood is going to travel to the lung, and see, whenever the blood moves from the heart towards the body, it is through the arteries. And whenever the blood comes back to the heart from the body, it is through the veins, right? This is the basic difference between arteries and veins. Artery will carry the blood from the heart to the body, and veins will carry the blood back to the heart from the body, right? So from here, what you see is, though the blood is deoxygenated, right? So though the blood is deoxygenated, it is still in an artery, and this artery is called as a pulmonary artery, right? So what you see here is, this is your pulmonary artery. 99% of the time, your arteries will always have oxygenated blood, except for this pulmonary artery, right? So now this deoxygenated blood will go to the lungs where the gas exchange is going to happen, right? So now the carbon dioxide will be taken out from the blood and in return, it will be replaced with oxygen, right? So now this oxygenated blood will not go to the body directly, right? It has to come back to the heart again. So from here, what you see is from the lungs, the blood will come back to the heart. And where will it reach? It will reach the right atrium, right? Through a vein, and that's called pulmonary veins, right? So this is again not exactly the role which your vein does, right? Most majority, I'll say 99% of the time, your vein will carry deoxygenated blood, except for this pulmonary vein, which has oxygenated, which is coming from the lungs to the heart, right? So from here, it will enter the left atrium and then it is pushed back into the, what happens is the atrium contract, pushing the blood into the left ventricle. And this is how the circulation happens, right? It is not this way, right? So what happens? Both ventricle contracts, pushing the blood out, one sending the blood towards the body, one sending the blood towards the heart, right? And then both the atrium will receive the blood together, right? So one receiving oxygenated and one receiving deoxygenated, right? So this is exactly. But what you need to know here is the heart will also have some valve, right? So these valves are important because what you see here is now you have a bicuspid valve, right, which is between your left atrium and your left ventricle, which you can see it here, right? So this bicuspid wall ensures that there's no backflow, right? So these are basically walls that allow the blood to move in one direction, right? Because as the atrium squeezes, the blood is pushed into the ventricles. Now, once the ventricle pushes or squeezes, the blood has to move towards the body, right? If there is a problem with the wall, the blood is going to go, I will say, pushed back into the atrium, which can be a defective valve, right? So now all these valves are there to prevent the black flow and responsible for the blood to move only in one direction, right? So again, here what you can see, let me use this, right? So here you have your uh, mitral valve, right? Here, what you can see is your tricuspid valve. So a bicuspid valve means it's something. Bi means two, tri means three, right? So bicuspid valve is also called as a mitral valve for your reference, right? Then again, when you see here, so you see now here what happens from the left ventricle, the blood is going to enter the aorta, right? So before it enters the aorta, there is also one valve, and that is called an aortic semilunar valve, right? So this again ensures that the blood does not come back to the ventricle again, right? So every place there is a valve, right, preventing the reverse flow and ensuring that the blood moves only in one direction, right? So this was with your cardiovascular system. Let's understand further. So let me just quickly erase it. Right, so I hope this thing is clear, right? So here from again from the heart, what's important you to know is now the conduction system, right? So a conduction system is basically like an electrical circuit which ensures that your heart beats and at the right pace, right? So your heart main role is to ensure that it's a pump, right, which ensures that the blood reaches, or I'll say helps circulate the blood throughout the body, right? So what it how it functions is basically on an electrical conduction system, which has some main parts and most important role to play, right? So what you see here is your sinoatrial node, right? This is also called as a natural pacemaker, right? Which fires at around 60 to 80 times per minute, right? So it basically ensures that your heart beats at the right pace, right? So it is basically found at the right atrium. So if you can, let's locate, right? So what you see here is your sinoatrial node, right, which is the natural pacemaker, which beats, I would say, which fires at around 60 to 80 times per minute, right? Located at the right atrium, which ensures that it basically, what it does is basically it receives signal and then makes your atria to contract, right? So now once the signal is received, what it does, it forces the atrias to contract, pushing the blood into the ventricle together, right? So now once the atria contract, this is going to push the blood. But see what happens, right? It's a conduction system, so it has to ensure that it uh, 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 it works at the right pace, right? Because you don't want the heart to completely contract, right? You want, what you want is basically the atria to contract so that the blood is pushed into the ventricle, and once this happens, you want your ventricles to contract, right, pushing the blood towards the body. But at the same time, you want your atria to relax, right, so that they allow some blood to move inside it. So you have, what happens once the atria contract, what you have next is your internodal pathways, right, which you can see here. Uh, so here, right, it's the AV node, right? So now AV nodes basically carry the signal from the SA, right, which is your sinoatrial pacemaker, to the AV node, right? So you have your I just made a mistake, right? So you have your internodal pathway, which is like an electrical circuit here, right, which takes the signal from the pacemaker to the AV node, right? So now AV node is basically an atrioventricular node, which is has an important role to play, which is to delay the signal briefly, right? So why it needs is basically you don't want everything to contract at the same time. What you want is the atria to contract followed by the ventricles to contract, sir, right? So this AV node plays an important role, which is delay the signal briefly, right? So this gives time for the blood to move from the atria to the ventricle, right? So now what happens is pushing the bloods into the ventricle. So now you have, uh, once the ventricles fill in, then you have your AV bundle, right? Which is, you can see here, available. So it's okay if it's not there, right? So basically what this AV bundle does, right, passes the signal from the AV node into the ventricles, right? So once the atria contracted, then the signal has to move to the ventricle. So this AV bundle helps move the signal or pass the signal from the AV node to the ventricles, right? So where you can see your left and right bundle branch, right? So what they do is basically carry the signal down to both sides of the heart, right? So now once, so let's understand this process step by step. First, the signal is received at the SA node, right? So from the SA node, it is to move to the AV node, right? So now AV node to SA node, you have your internodal pathways. AV node, what it does basically delays the signal before it passes the signal to the ventricles, right? So now from this, the signal is going to be received by the left bundle branch and the right bundle branch, right? And then you have your Purkinje fibers, which you can see here, right? Now this is going to help spread the signal throughout your ventricles, right? So this is what the process, and once the signal is received, the ventricles are going to contract, pushing the blood out of the body, right? I will say out of the heart, sorry, out of the heart, right? Just quickly erase this. Right, so let's see here, right? So now how the conduction system work is simply is your signal, right? The signal is first received by the SA node, which is your sinoatrial node. From the sinoatrial node, this signal is carried forward through your internodal pathways, right, to the AV node. What this AV node does is basically help delay the signal, right? So delay and help uh, I'll say, I will say not just delay, but then also pushes or I'll passes the signal to the AV bundle, right? Which is basically the bundle branches. And now from here, this bundle branches will spread the signal across the ventricles with the help of this Purkinje fibers, right? So what you need to remember here is your sinoatrial node is important because it helps you control your heartbeat, right? So then the next thing that you need to remember is the AV node, which is important to delay the signal slightly so that it allows the atria to fully empty into the ventricles, right? Empty the blood into the ventricles. And then the ventricle signals receive the signal last and contracts together, pushing the blood out of the heart for a strong heartbeat, right? So this is how your cardiovascular system works along with your electrical conduction system, right? So if someone's experiencing a heart attack like symptom, what he is suggested is to do a what do you call that? I just ECG, right? So what he's proposed or suggested to do is now undergo an ECG, immediate ECG, because that ECG is going to help understand whether there is any problem with the electrical conduction system, which is very important because if there is a problem with the circuit, then it's a medical emergency. So if there is no problem with the conduction system, it may be something, right, which can be identified or assessed or diagnosed using other techniques, right? So this was it for with this topic, right, which is the cardiovascular system. I hope you're liking my videos. Do like to share and surprise. Thank you, guys.